Hi there, these are the 5 past NEET questions that we will solve in this video. It is of the level of high school physics. They are related to thermodynamics. You can pause the video at any time to give a try yourself. Let's begin. For this first question, if you read carefully, it says there are 2 systems, one with small radius piston and the other with bigger piston. The radius are RA and RB. The other parameters like pressure P are same, heat input, delta Q are same, change of internal energy is same. We invoke the first law of thermodynamics, and that has delta Q and delta U the same. So the work done in both systems must be the same. For reversible process, work is pressure times change of volume. Pressure is same, so it cancels. In the question it is given that piston A moves 16 centimeters and piston moves 9 centimeters. And area of the piston is pi times the radius square. It gives the following equation. We do some algebra to get the ratio of radius to be 3/4. So the answer is D. Let us now go to next question. In this problem, we look at the figure. They are asking us to find work done by isobaric process, which is A to B. By the way, it is a good idea to revise similar-sounding process. Isobaric process is the process where the pressure is the same. Isochoric process is where the volume remains constant, and isothermal process is where the temperature remains constant. In PV diagram, we can identify the process. When the system goes from A to B, it is isobaric process. When the system goes from C to A, it is isochoric process. Isothermal process cannot be identified in PV diagram. Let us now come back to problem. Work done in isobaric process is area under A to B. It is green rectangular area. This is 3 times 10 to the power of 2 times 2, the change in volume. It is 600, and the answer is D. Let us go to next problem. This problem is asking which equation is valid for adiabatic process. You must start from an easy memorizable formula for adiabatic process, which is P times V to the power of gamma equals some constant. In the answer choice, in some cases, they do not have V, and in other cases, they have no P. So we use the ideal gas equation and substitute for V or P as the case may be. We do 2 ways. If you are lucky in the first try, we substitute for V and we get the answer. If you try other way of substituting P, you will not get the answer. One has to try both ways. If you are lucky, you may get answer on the first try. Let us go to next question. Here they are asking why they use water as coolant in nuclear reactor. The answer is high heat capacity because you should use fluid that can take away the heat without raising much of temperature. Other factors like thermal expansion does not matter. Low density and low boiling point do not vary more for water to other liquid, so it should not matter. Hence, the choice is water. For a kilogram of water, it can absorb more heat for rising the temperature of 1 degree centigrade. That is the definition of specific heat capacity. Water is unusual in that it has high specific heat. This table shows the comparison of specific heat of liquids. The answer is B. I like to say something more about importance of water having high specific heat. In fact, the reason for having moderate climate for cities near the sea because water has high specific heat compared to dry soil. The figure shows, in the day, the dry soil quickly get heated by sun, and the air rises. The sea, on the other hand, is cool from the previous night due to high specific heat, and we get the cool sea breeze to the land. In the night, the process happens in reverse. So do not forget that our weather is so much influenced by high specific heat of water. I hope you liked the interesting diversion. Let us go to the next question. This is a good question they tell you to see the figure. The curved lines are approximated by the associated dashed lines. Each dashed lines represents one system under the constant pressure, P1, P2, and P3 respectively. So in total, we have 3 systems. Each dashed line show you the temperature versus volume graph. You can see they are straight line representing the Charles's law. They ask you to quantitatively say about the pressure in the 3 systems. So far, we are only understanding the figure. Now, let us find the answer. We draw a vertical line, so that volume on the line is constant. Now, we look at the intersection points. We expect ideal gas equation to be valid. Under constant volume, the pressure should be proportional to the temperature. So as we go up, the intersection point should represent for the higher pressure. So as we go up, first we encounter pressure P3, it must be least. As to go higher in temperature, we hit at P2 and lastly at P1. So P1 is the maximum and P3 is the minimum and P2 in between, and the answer is D. One can also do it another way, by drawing horizontal line. Let us do that in next page. If we draw the horizontal line, the temperature is constant for the line. Now again, the ideal gas equation is valid. Under constant temperature, P is inversely proportional to volume. If you remember, that is Boyle's law. So, as we go from left to right in the line, the first intersection has less volume and P1 has to be more. Then we hit pressure P2, which is lesser as volume is more, and P3 point is the least and volume is maximum. So we get the same answer, as we should. P1 is greater than P2 is greater than P3. This ends the video. I hope you like the video. Please subscribe and like the video. Thank you, and bye for now.